A sine wave is a signal that has just one frequency. It represents the motion in one direction coming from a cyclical pattern that changes at a constant rate. It's a speaker cone that moves forward and backward. In MATLAB, there's a built-in function that we can use called Sine for synthesizing our sine wave. Let's take a look at that. Here are the steps that you can use to synthesize a sine wave. I'm going to start out by initializing some variables. For our signal, I'm going to pick a sampling rate of 48,000 and assign it to a variable fs. From here, we can calculate the sample period, or the duration of time between samples. This is 1 divided by our sampling rate. These things are helpful to have when we're going and determining the length of the signal that we want to synthesize. Up next, we'll create a variable t, which is an array. It contains the time samples of our signal. So we'll start at time 0, and we'll go up by our sampling period, ts. Now we're going to pick the duration in seconds of our signal. For now, I'm going to pick 13 for 13 seconds. Now we've created an array t that we can use with the built-in sine function in MATLAB. So here we'll type sin, then use parentheses, and inside of the parentheses, put t. We're going to assign the result of this function to a new variable y. Y is going to be our signal, that's our sine wave. So I can execute this command. Now, to look at the result of this command, let's go ahead and plot. Plot t as our horizontal axis against y. Let's look at the result of what we've synthesized. Here we've created a signal, as you can see, that goes through the sine wave pattern. Starts over here at time 0, and it goes through a couple cycles over these 13 seconds. Let's take a closer look at the duration of each cycle. I click on this button here. I can look at the value of y against the value of x. So we're looking for the timing where we go through a complete cycle. So here's right about the end of the first cycle and the beginning of the second cycle. If we look closely, we're right around 6.28. In fact, the duration of one cycle that we've synthesized is going to be 2 pi, about 6.28. You can look at half of a cycle over here, should be about 3.14. So in 13 seconds, we've gone through a little over 2 cycles. Now, normally when we're working with audio, we're thinking in terms of hertz, number of cycles per second. So a common thing to do with the sine function is add a multiplication in so that our signal is repeating 1 time every 1 second instead of 1 time every 2 pi seconds. So what we can do is go back here where we're using the sine function. Before, instead of just having t, what I'm going to do is multiply by 2 pi. And we'll look at the result, what that's going to do. 2 times pi times t. It's going to change the sine wave signal that's created. So now if I go to plot this, we'll see that the number of repetitions or cycles has changed. Instead of going through about 2 cycles, now we're going through a total of 13 cycles. So we go through 1 cycle for every 1 second. So this is easier to see. Let's change our time vector t. So instead of lasting 13 seconds, we can sort of zoom in and look at just a couple cycles. So t here, instead of going up to 13 seconds, let's just make it go up to 2 seconds. Now, I can call sine 2 pi t and look at the result. We should just see 2 cycles for every 2 seconds of our signal. So now we've come up with a way to synthesize 1 cycle per second. Now, a lot of times with audio, we like to be able to control the frequency. So have 1 cycle per second, usually, with audio, somewhere between 20 and 20,000 cycles per second. So the common thing to do is have another variable called f, which stands for the frequency. You can put in whatever number you want for the frequency and have that change how many cycles per second we have. So let's create a variable f here. Say f is equal to 3 for now. Just see what the result is and how to use it. So here, we're going to say f is equal to 3. So what we're going to put into the sine function is 2 times pi times f for frequency times t. Now, let's go ahead and plot the result. We've changed the frequency, the length of our cycle, So if you go through up to 1 second here, we now have a signal where we can specify as the programmer the exact number of cycles we want to go through for every 1 second. The last parameter that I'll show you here with the sine function is how we can do a phase offset. So rather than always starting at 0 degrees or 0 radians, what we can do is do a phase offset. So it starts at maybe a peak or a valley in our cycle. So here, I'm going to create a new variable, phi. And the range that phi can take on is from 0 up to 2 pi. So here, why don't I put in, how about pi over 2? So this is about 90 degrees. Let's look at how we can use this in our sine function. We have 2 times pi times f times t. And then I'm going to add in afterwards a phase offset. It's still within the parentheses though. Now let's go ahead and plot our result. Instead of starting at 0 radians or 0 degrees, now the beginning of our signal at time 0 starts all the way up here at this peak. We can pick whatever point we want, anything between 0 and 2 pi. So I can change the phase offset. How about 3 times pi divided by 2? This should be at 270 degrees. So change the function again and plot it. Now we're starting down here at the bottom at -1. The last thing I'll show you in this video then is let's synthesize a signal that we can actually listen to rather than just visualizing it. So here I'm going to set our phase offset back to 0. Start from 0. And let's pick a frequency that we can hear. How about f is equal to 440 hertz. Now, when I synthesize our signal by using this function call and assigning it to y, we're going to create a signal that we can listen to. So it's better to do this than plot it. I'm going to do sound, I'm going to put in y, and then our sampling rate. So should be able to execute this command and listen to the result. So now we've been able to synthesize a signal that has a duration of 2 seconds that we set, and it has a frequency of 440 hertz. Those are the steps necessary to create a sine wave signal based on these common parameters that we work with as audio engineers.